Hello everybody, welcome into another lesson. So today we are going to talk about solving quadratic equations by the method of finding square roots. So this is a nice method if you have no x to the first term. Usually if you just have some form of x squared equal to a coefficient, or to a constant rather. So this particular equation, we have x squared equals 121. Well, the idea is we want to solve for x, but remember, since x is to the second power, we're actually going to have two solutions. So when you go to solve for x, what you have to do, you take the square root of x squared, set that equal to, now you just take the square root of x squared, but the right hand side, which is the number it's equal to, you're going to take both plus and minus the square root of 121 in this case. A lot of people end up missing a solution. They only take the positive square root. They forget that you have to consider the negative square root of the number also. So the left side, square root of x squared, you would get x, you just get x, that'd be equal to plus or minus the square root of 121, that's plus or minus 11. And the reason for that is, of course, if you take positive 11, set it to the second power, you would get positive 121. But if you took negative 11, set it to the second power, you would also get positive 121. So there's actually two solutions then. X would equal both plus and minus 11. And remember, the degree of the equation, the degree of the equation indicates how many solutions you're going to have. So if it's a linear equation, to the first degree you'll just have one. If it's a second degree, you'll have two. If it's a third degree, you'll have three solutions, and so on. In the complex number system, I should say. Maybe not in the real numbers, but somewhere in the complex system you will. Next lesson, we're actually going to get into complex numbers, but we'll stick with the real numbers today. Now, let's say we had something like x squared is equal to 90. So x squared equals 90. Well, again, we can solve for this by taking the square root of the left side, which is the square root of x squared. You'll set that equal to both plus and minus the square root of 90. Well, of course, the square root of x squared is going to be x. That's going to equal still plus and minus, but here's something. The square root of 90, can't we break down the 90 into 9 and 10? Remember, that'll break down into the square root of 9 times 10, which if you have two factors under the square root, you can actually break those down into two separate square roots. So that would break down into plus or minus the square root of 9 times the square root of 10, which would actually turn into x equals plus or minus 3 times the square root of 10. That would be your solution. X equals plus and minus 3 times the square root of 10. In order to get the proper answer, your radical expression must be in simplest form, meaning you factored out any perfect squares. 9 is a perfect square, 10 is not. You can't factor 10 any further, but 9 is a perfect square. So that would break down into x equals both plus and minus 3 times the square root of 10. All right, what do we have now? We have 3x squared is equal to 108. So we're given 3x squared equals 108. First thing I'm going to suggest is let's get the x squared by itself, make it the coefficient a 1, so you divide both sides by 3, you would get that x squared is equal to 36 when you divide both sides by 3. And then now you'll just take the square root of x squared, you'll set that equal to both plus and minus the square root of 36. Square root of x squared is x. That's going to equal both plus and minus. Now, what is a square root of 36? That would just be 6. So x equals both plus and minus 6 would be your solution to this. All right, let's see. We have 2x squared plus 5 equals 41. So you're given 2x squared plus 5 equals 41. Well, first thing you want to do is get the 2x squared by itself. So subtract 5 from both sides. You'll end up getting 2x squared is equal to 36. Now we just want to get the x squared by itself, so divide both sides by 2. You'll end up getting x squared is equal to 18. Now, of course, we can go ahead and solve for x by taking the square root of x squared. Set that equal to both plus and minus the square root of 18. So square root of x squared is equal to x. That would equal plus and minus. Now, 18 breaks down into factors of 9 and 2, right? 2 is not a perfect square, but 9 is. This would be plus or minus the square root of 9 times the square root of 2, which means x would be equal to plus or minus 3 times the square root of 2. So that would be your solution. X would equal both plus and minus 3 times the square root of 2. All right. Now, we have negative x squared minus 12 equals negative 87. So we have negative x squared minus 12 equals negative 87. Well, let's get that negative x squared by itself, so let's add 12 to both sides. If you do that, you'll get negative x squared is equal to negative 75. So negative x squared equals negative 75. Well, we want to just get x squared by itself, so we got to divide both sides by negative 1. If you do that, you'll get x squared equals positive 75. And then now we can go from here, take the square root of both sides. So take the square root of x squared. That's going to equal both plus and minus the square root of 75. Well, square root of x squared is just x. That would equal plus and minus. Okay. 25 has factors of, 75 has factors of 25 and 3, right? 3 is not a perfect square, but 25 is. So this will break down into plus and minus the square root of 25 times the square root of 3, which would mean that x is equal to plus and minus 5 times the square root of 3. So those would be your two solutions. X equals both plus and minus 5 times the square root of 3. All right, let's see. We have 7 minus 10u squared is equal to 1. Well, that's going to be a good one. 7 minus 10u squared is equal to 1. Well, let's get that negative 10u squared by itself, so subtract 7 from both sides. If you do that, you'll end up just getting negative 10u squared is equal to negative 6. Now we just want to get the u squared by itself, so divide both sides by negative 10. You would get u squared is equal to negative 6 divided by negative 10 would turn into positive 3/5. So u squared is equal to 3/5. Now we'll just take the square root of both sides, so square root of u squared equals both plus and minus the square root of 3/5, which when you're dividing, the square roots also separate just like they do when you're multiplying. So this will be plus or minus the square root of 3 over 5. But do we remember from Algebra 1 what you have to do? This is not in simplest form yet. In order for a quotient of radicals to be in simplest form, you have to eliminate the radical from the denominator, which means you have to rationalize the denominator. In order to do that, I have to multiply both numerator and denominator by the square root of 5. So if I do that, I'll end up getting u on the left-hand side would equal plus or minus square root of 3 times the square root of 5 is the square root of 15 over the square root of 5 times the square root of 5. If you have a square root of one of a number times the square root of the same number, it just cancels out the square root. So you would have plus or minus the square root of 15 over 5. That's what u would be equal to. Plus or minus the square root of 15 over 5. I know that one seemed like a doozy. Alright, what do we got next? We have v squared over 25 minus 1 equals 11. So v squared over 25 minus 1 equals 11. I'm going to suggest we start by getting that v squared over 25 by itself. So add 1 to both sides. You do that, you'll simply get v squared over 25 is equal to 12. Now we just want to get the v squared by itself, so just multiply both sides by 12. Left side, multiply both sides by 25. If you do that, the left side just turns into v squared. That would equal 12 times 25, that's 300. So you would have v squared is equal to 300. Now we'll just take the square root of both sides. So square root of v squared is equal to both plus and minus the square root of 300. So yeah, the square root of v squared is v. That's going to equal plus and minus. Now 300, what are factors of that? You have 100 times 3, don't you? 3 is not a perfect square, but 100 sure is. Plus or minus the square root of 100 times the square root of 3, which means v would be equal to plus or minus 10 times the square root of 3. So the solution, the two solutions I should say, are v equals plus or minus the square root of plus or minus 10 times the square root of 3. Alright, 6 minus p squared over 8 equals negative 4. So we have 6 minus p squared over 8 equals negative 4. First thing I suggest is we get that negative p squared over 8 by itself, so subtract 6 from both sides. You'll just end up getting negative p squared over 8 is equal to negative 10. Now we have negative p squared over 8 equals negative 10. I'm going to suggest we just get the p squared by itself. So you're going to have to multiply both sides by negative 8. If you multiply the left side by negative 8, you would just get p squared is equal to positive 80. So p squared is equal to 80. Now we can go ahead and solve for p. Take the square root of both sides, you'll get the square root of p squared is equal to both plus and minus the square root of 80. Well, square root of p squared is certainly p. That's going to equal plus and minus. Now, what are some factors of 80? Well, 16 and 5, right? 5 certainly isn't a perfect square, but 16 is. So you'd have plus or minus the square root of 16 times the square root of 5, which would have to mean then that p equals plus or minus 4 times the square root of 5. So those would be your two solutions for p. P equals plus and minus 4 times the square root of 5. All right. we have 5q squared over 6 minus q squared over 3 is going to be equal to 72. So we have 5q squared over 6 minus q squared over 3 equal to 72. Well, let's find a common denominator on the left-hand side. That's obviously going to end up being 6. So this will turn into 5q squared over 6 minus 2q squared over 6 would still equal 72. So then you would end up having 3q squared over 6 equals 72. Now watch this. 3q squared over 6 would just turn into q squared over 2. Q squared over 2 would equal 72. Which we can get q squared by itself if we just multiply both sides by 2, right? So that would simply give you q squared would equal 144. So q squared equals 144. Now we can go for the square root. So take the square root of q squared, set that equal to both plus and minus the square root of 144. Well, square root of q squared is q equals plus and minus. Now, good news is square root of 144 is a perfect square, so that would just be plus and minus 12. So q equals both plus and minus 12 in this situation. All right, so that's it for those problems. Now, I got some where you'll have quantities to the second power equal to a number on the right-hand side. So what if we had 2 times the quantity of x minus 3 raised to the second power set equal to 8? So we have 2 times the quantity of x minus 3 raised to the second power equal to 8. Well, one way would be to, of course, expand all this out and then try to get into a simpler quadratic equation and hope we can factor it and then solve, or use the quadratic formula or complete the square or something. Or there's a much easier approach. You could treat that x minus 3 just like you would x. So let me show you. First thing I'm going to suggest is we get that x minus 3 squared by itself. So divide both sides by 2. So you would get x minus 3 to the second power would equal 4. You divided both sides by 2, you made your life a lot easier. Now, we're going to do this much the same way. You're going to take the square root of the x minus 3, that quantity squared. You're going to set that equal to plus and minus the square root of 4. So the square root of x minus 3 squared would just become x minus 3. That's going to equal plus and minus the square root of 4, which is 2. So x minus 3 equals plus and minus 2, which means x would equal 3 plus and minus 2. Well, we have two different solutions. If we take x equals 3 minus 2, x would equal 1. If we take x equals 3 plus 2, x would equal 5. So the solution to this is going to be x equals both 1 and 5. Those are the two solutions. And if you put either of those in for your x values, you would in fact get a true statement. All right, so let's see. 4 times the quantity of x plus 1 squared is going to equal 100. So 4 times the quantity of x plus 1 squared equals 100. Well, I would suggest we just get that x plus 1 squared by itself, so divide both sides by 4. You'd end up getting x plus 1 squared would equal 25. So now you have something easier to work with. X plus 1, that quantity squared, equals 25. Now we can take the square root of both sides. So take the square root of the quantity of x plus 1 to the second power. You'll set that equal to both plus and minus the square root of 25. So on the left side, this will just turn into x plus 1. That would equal plus and minus square root of 25 is just 5. So x plus 1 equals plus or minus 5, which means x equals negative 1 plus or minus 5, which means, again, we have two solutions. X would equal, let's see, negative 1 minus 5 is negative 6. Negative 1 plus 5 is positive 4. So x would equal both negative 6 and positive 4 as your solutions. All right, next. We have negative 3 times the quantity of x plus 2 raised to the second power is equal to negative 18. So negative 3 times the quantity of x plus 2 to the second power equals negative 18. Well, definitely get that x plus 2 to the second power by itself, so go ahead and divide both sides by negative 3. You'll end up getting x plus 2 to the second power is equal to positive 6. Now we can take the square root of both sides. So take the square root of the quantity of x plus 2 to the second power. That's going to equal plus or minus the square root of 6. So on the left side, we'll just simply turn into x plus 2 would equal, now, square root of 6 is not a perfect square, and none of its factors are. So you'd just have x plus 2 equals plus or minus the square root of 6. So then you can just say x would equal negative 2 plus or minus the square root of 6. And that's the best you can do, since 6 isn't a perfect square, nor are any of its factors. So x would equal negative 2 both plus and minus the square root of 6. That's how you would write the solution. All right. We got 5 times the quantity of x minus 7 to the second power is going to be equal to 135. All right, so 5 times the quantity of x minus 7 raised to the second power equals 135. Well, first, why don't we get that x minus 7 to the second power by itself? So divide both sides by 5. On the left, you'll just get x minus 7 raised to the second power equals 135 divided by 5. So that would end up giving you 27. So you would end up getting x minus 7 raised to the second power equals 27. Now we can take the square root of both sides. So the square root of the quantity of x minus 7 raised to the second power equals plus and minus the square root of 27. So then you end up getting, of course, the left side, x minus 7 equals plus and minus, okay. 27 breaks down into 9 and 3, right? 3 is not a perfect square, but 9 is. So you'd have plus and minus the square root of 9 times the square root of 3, which means x minus 7 equals plus and minus 3 times the square root of 3. And then all you can do for x is just say x equals 7 plus and minus 3 times the square root of 3. And that's as far as we can get, since the square root of 3 is not a perfect square. So x would equal 7 both plus and minus 3 times the square root of 3. That would be your solution. I have about 5 more. We have 8 times the quantity of x plus 4 squared equals 9. So 8 times the quantity of x plus 4 squared equals 9. Well, okay, get that x plus 4 squared by itself. That, of course, is going to end up giving you, if you divide both sides by 8, you'll end up getting that x plus 4 raised to the second power would equal 9/8. So x plus 4 raised to the second power equals 9/8. Now we can take the square roots of both sides. So the square root of x plus 4 raised to the second power would equal plus and minus the square root of 9 over the square root of 8. So the left side would just simply turn into x plus 4. That would equal, well, square root of 9 is 3, so you'd have plus and minus 3 all over square root of 8 breaks down into square root of 4 times the square root of 2, so this would turn into 2 times the square root of 2. Well, this is still not in simplest form yet. You need to rationalize the denominator, which means to get the square root out of it. So you'll just multiply both sides, both numerator and denominator rather, by the square root of 2. This would turn into x plus 4 equals plus and minus 3 times the square root of 2 over 4, which then simply put x would equal negative 4 plus and minus 3 times the square root of 2 all over 4. And that's about the best we can do. X would equal negative 4 plus and minus 3 times the square root of 2 over 4. That's the best we can do for that. All right. We have 2 times the quantity of a minus 6 raised to the second power, which is going to be equal, actually, that's not it. 2 times a to minus 6 to the second power minus 45 is going to be equal to 53. Alright, so 2 times the quantity of a minus 6 raised to the second power minus 45 equals 53. I'm first going to suggest that we get that 2 times the quantity of a minus 6 to the second power by itself. So add 45 to both sides. If you do that, you'll get 2 times the quantity of a minus 6 raised to the second power set equal to 53 plus 45 is 98. So you'd have 2 times the quantity of a minus 6 to the second power equal to 98. Now let's just get the a minus 6 to the second power by itself. So divide both sides by 2. You end up getting a minus 6 to the second power equals 49. Now you got something you can work with. We'll just take the square root of both sides. So the square root of the quantity of a minus 6 to the second power would equal both plus and minus the square root of 49. So square root of the left side would just turn into a minus 6. That's going to equal plus and minus. Good news is 49 is a perfect square, so that'd be equal to plus and minus 7. So that means a would equal 6 plus and minus 7. So your two solutions, if you take 6 minus 7, you would get negative 1, and then 6 plus 7 would give you positive 13. So your two solutions for a are a equals negative 1 and positive 13. I got 3 more problems here. Alright, good one. So we have 1/4 times the quantity of b minus 8 raised to the second power is equal to 7. Alright, so we have 1/4 times the quantity of b minus 8 to the second power equals 7. Well, I think we should just get that b minus 8 to the second power by itself first. So let's multiply both sides by 4. You do that, you'll end up getting the quantity of b minus 8 raised to the second power would equal 28. So now you have b minus 8 to the second power equal to 28. Now we can proceed to take the square roots of both sides. So the square root of b minus 8 raised to the second power is going to equal plus and minus the square root of 28. So the left side, well, you would just get b minus 8. That equals your right side. Plus and minus. Now, square root of 28, okay, 28's not a perfect square, but we have factors of 4 and 7, where 7's not a perfect square, but 4 certainly is. You would get the square root of 4 times the square root of 7, which would just turn into 2 times the square root of 7. So now you have b minus 8 equals plus and minus 2 times the square root of 7, or simply put b equals 8 plus and minus 2 times the square root of 7. So your two solutions for b are that b equals 8 both plus and minus 2 times the square root of 7. I have two more. Different. We have the quantity of 2r minus 5 raised to the second power is going to be equal to 81. So we have the quantity of 2r minus 5 raised to the second power equals 81. Well, let's still take the square root of both sides. So take the square root of the quantity of 2r minus 5 raised to the second power. Set that equal to both plus and minus the square root of 81. Well, 2r minus 5 to the second power, the square root of that would just turn into 2r minus 5. Now, that would equal plus and minus. Well, here's some good news. 81's a perfect square. That would just be 9. So you'd have 2r minus 5 equals plus and minus 9. Now we'll solve for 2r. 2r equals 5, both plus and minus 9, which means that 2r is going to equal, well, 5 minus 9, what's that? That's negative 4. And then you would have 2r also equals, then this time 5 plus 9, that equals 14. Now just take each of these, divide them by 2. R would equal both negative 2, and then 2r equals 14. R would equal 7. So the two solutions here are that r equals negative 2 and positive 7. That's what you'd end up getting. One more. Oh, yes. The quantity of s plus 1 to the second power divided by 10 minus, am I reading that right? Yes, 12/5 is going to be equal to 15/2. Alright, so we have the quantity of s plus 1 to the second power divided by 10 minus 12 over 5 equals 15 divided by 2. And at first glance, this looks horrendous, doesn't it? But for all of these, we want to get a common denominator, right? Well, the common denominator should be obvious, would be 10. So if we just multiply both sides by 10, we can get rid of any fractions. So multiply the first term of the left side by 10, you'll just end up getting the quantity of s plus 1 squared minus, now you multiply the second term by 10, the 5 will cancel out from that. You'll just end up having minus 2 times 12, which would be minus 24. is going to equal now the right-hand side. Multiply the right-hand side by 10. 2 cancels out from that. You would get 5 times 15, which is 75. So you'd end up getting s plus 1 squared minus 24 equals 75. Now let's just get the s plus 1 squared by itself. To do that, add 24 to both sides. You'll get s plus 1 to the second power would equal 99. So s plus 1 to the second power equals 99. Okay. Now, let's take the square root of both sides. So the square root of s plus 1 raised to the second power equals both plus and minus the square root of 99. So the left side, that'll just simply turn into s plus 1. That'll equal, okay, plus and minus still. Now, square root of 99 itself is not a perfect square, but we have factors for 99 of 9 and 11. 11's not a perfect square, but 9 certainly is. So the square root of 9 times the square root of 11 would equal 3 times the square root of 11. So s plus 1 equals plus and minus 3 times the square root of 11. Then simply put, s would equal negative 1, both plus and minus 3 times the square root of 11. And that would be the two solutions to this. S equals negative 1 plus and minus 3 times the square root of 11. So that's it for using square roots to solve quadratic equations. Next lesson, we are going to introduce imaginary numbers and talk about what they are, what they're used for, and explain how they relate to the number systems and to the set of complex numbers. So I hope everyone has a great night. Take care.